Before y'all get mad at me for the thumbnail, this is what Andrew Clark from the React core team actually tweeted. It might not be quite as extreme, but this is some big news. And I think we need to talk about it because throwing away use memo, use callback, memo, forwardRef, react.lazy, use context, throw promise, and context providers, there's a lot changing right now. So what the heck's going on? Why is all of this going to change? Well, first and foremost, it's important to know none of this has to change. You can continue using things the way you currently use them, and even in new React versions, you're going to be fine. I don't think they have any intention to deprecate the existing functionality at any point. You just won't necessarily need the things on the left side here in the future. Some of them are just semantic changes like context.provider becoming just context because you no longer need to use context. You can just call use with the context. There's also some performance benefits we'll talk about in a bit. But we need to read the official update from the React core team. React Labs, what we've been working on, February 2024. These blog posts are great, and they haven't been doing them quite as often as I would have hoped. Like the last one was that a year ago? Yeah, March 2023 was the last one. So it's been almost a year since the last of these updates. Very thankful they're still happening. And also, Dan's still helping out. The first update is React Compiler. React Compiler is no longer a research project. Yeah, we mentioned that before in the tweet. As discussed in their previous post about it, React can sometimes re-render too much when state changes. Since the early days of React, our solution for such cases has been manual memoization. In our current APIs, this means applying use memo, use callback, and memo APIs to manually tune how much React re-renders on state changes. So if you have an element that you don't want to have re-render because the things you're passing to it didn't change, but maybe a hook above that did, you could memoize the component, you could memoize the data. There's a lot of places you can throw these checks to keep those updates from happening. But even knowing that you can do that, much less how to do it and how to do it properly, is a big ask for a dev that's just trying to have an input field that responds when they type. I'm very thankful to know that in the future, they won't have to do that without having to adopt a whole different mental model like signals. Oh, look at that. They're saying the same thing here. Manual memoization is a reasonable compromise, but we weren't satisfied. Our vision is for React to automatically re-render just the right parts of the UI when state changes, without compromising on React's core mental model. First part is, yeah, that's solid.js. You can use other things for this. But wait, without compromising on React's core mental model. There's the difference. Svelte and Solid and all these other solutions have their own gotchas with how state is encapsulated, how you have to call things instead of using values, how equals is bound to weird behaviors in Svelte, all these types of things that React does a pretty good job of sidestepping, where I still feel like React feels the most like just JavaScript of modern frameworks. Solid is really close, but React still is the most JS vibe I get. And that's a huge part of their core mental model, as well as the composability of all these pieces and the way that those interface together. Back to the post. We believe that React's approach, UI is a simple function of state with standard JavaScript values and idioms, is a key part of why React has been approachable for so many developers. That's why we've invested in building an optimized compiler for React. JavaScript is a notoriously challenging language to optimize, thanks to its loose rules and dynamic nature. React Compiler is able to compile code safely by modeling both the rules of JavaScript and the rules of React. For example, React components must be idempotent, returning the same value given the same inputs, and they can't mutate props or state values. These rules limit what developers can do and help to carve out a safe space for the compiler to optimize within. Of course, we understand that developers sometimes bend the rules a bit, and our goal is to make React Compiler work out of the box on as much code as possible. The compiler attempts to detect when code doesn't strictly follow React's rules and will either compile the code where safe or skip compilation if it isn't safe. We're testing against Meta's large and varied code base in order to help validate this approach. There is so much good information in here. So first off, lint rules as a way to make the code more optimizable, that's a bit scary. We've all had lint rules that prevent you from doing things that are obviously not performant or have weird side effects. But the idea of lint rules that are specifically to keep you within the bounds of the JavaScript that the React compiler is the most capable of optimizing, that's an interesting concept, like genuinely really interesting. And I'm curious how that plays out. The other part is that a lot of your code isn't going to fall within that optimizable set. And when that happens, you can't just opt out of the compiler entirely. Like, how do you deal with that? I'm sure there's a lot of code in the Instagram code base, period. But importantly here, there's a lot of code in the Instagram code base that probably doesn't follow these rules exactly. And that's why this callout is so important, because if it works there and they're able to make it work around those things, maybe you don't get the same performance win, but at least it's compatible. That's huge. And historically, React's been really good about this. In the past, other frameworks like Angular, when they had major updates from AngularJS 1 to Angular 2.0, you couldn't just use old code. In my Always Betting on React video I did last year, I gave the example of taking a component from this blog from 2014 in putting it in a brand new app router Next.js RSC project and actually server rendering that ancient class component. React's historically been incredibly backwards compatible, which is a huge part of why hooks could take off the way they did, because I could just update React versions, all the old code still worked, but I could make new components with hooks and even mount old components with classes inside of those new components and intermingle them effortlessly. That's how I do things with server components largely too. It's surprisingly easy to take code from the old era and use it in this new stuff, and it all just works together like the Lego bricks they built. But if the compiler is strict about what things it does and doesn't support, that all gets thrown away, which is why it's very good to hear they're building outs into the compiler. For developers who are curious about making sure their code follows React's rules, we recommend enabling strict mode and configuring React's ESLint plugin. These tools can help catch subtle bugs in your React code, improving the quality of your applications today, and future-proofs your applications for upcoming features such as React Compiler. There's going to be all the crazy rules of hooks and such. I should do a longer deep dive on why those are important. There's some crazy optimizations with hooks that y'all don't even know about. Anyways, we're also working on consolidated documentation of the rules of React and updates to our ESLint plugin to help teams understand and apply these rules to create more robust apps. Really good to hear that they're committed to making ESLint experience much better. Previously, the React team hasn't been as focused on these types of tools that are external ecosystem things. Like ESLint being mentioned this much in a React post is interesting to see. Even things like JS.doc comments on the type definitions aren't particularly interesting to the React core team. Things like that tend to fall on the shoulders of poor Matt Pocock, who's stuck making all of those definitions himself, but God bless him for it. Those are going to be a very nice IDE win. To see the compiler in action, you can check out our talk from last fall. Again, check out my video where I show the case this if you want to learn more about it. At the time of the talk, we had early experimental data from trying React Compiler on one page of Instagram. Since then, we've shipped the compiler to production across all of Instagram.com. We've also expanded our team to accelerate the rollout to additional services at Meta and to open source. We're excited about the path ahead, and we'll have more to share in the coming months. Oh boy. I cannot wait for this to be open sourced. I am so curious about the actual implementation details here. It's going to be a fun ride. Speaking of fun rides, let's talk about actions, which have been a particularly wild ride for me. We previously shared that we were exploring solutions for sending data from the client to the server with server actions, so that you can execute database mutations and implement forms. That's weird to reduce it to these two examples. There's a lot of other things you want to do with an action. I get what you're saying, though. The idea of having a proper built-in primitive for the client to send data to the server. Important stuff. During development of server actions, we extended these APIs to support data handling in client-only applications as well. Oh boy, they're formally blessing the use case of using server actions for client stuff. We refer to this broader collection of features as simply actions. Actions allow you to pass a function to DOM elements, such as form. So this is for Reactless JavaScript in a way. The action function can operate synchronously or asynchronously. You can define them on the client side using standard JavaScript or on the server side with useServer directives. When using an action, React will manage the lifecycle of the data submission for you, providing hooks like useFormStatus or useFormState to access the current state and response of the form action. By default, actions are submitted within a transition, keeping the current page interactive while the action is processing. Since actions support async functions, we've also added the ability to use async and await within the transitions. This allows you to show pending UI with the isPending state of a transition when an async request like fetch starts, and show the pending UI all the way through the update being applied. I'll be honest, the examples I've seen thus far for useFormStatus and useFormState are really hard to digest. It feels a little bit too much like magic at the moment. I need to make some really good ones so I can both communicate it better and confidently show it in my videos. Just know if these hooks make you feel a little dumb right now, you're not alone. Not only am I struggling to share how they work as like an educator, I haven't really implemented them in my apps just yet. So if anyone on the React team wants to bully me into using them, let me know. Use Optimistic, however, also very confusing. I have used it. It's really powerful. Alongside actions, we're introducing a feature named Use Optimistic for managing optimistic state updates. Within this hook, you can apply temporary updates that are automatically reverted once the final state commits. For actions, this allows you to optimistically set the final state of the data on the client, assuming the submission is successful, and revert to the value of the data received from the server. It works using regular async await, so it works the same whether you're using fetch on the client or a server action from the server. Library authors can implement custom action equals function props in their own components with use transition. Our intent is for libraries to adopt the actions pattern when designing their component APIs to provide a consistent experience for React developers. For example, if your library provides a calendar on select event handler component, consider also exposing a select action equals action API too. This is really interesting. I'm starting to see what they're going for here. Right now, if I have a component that has a loading state in it, and I want to use that loading state to render something differently above it, that kind of sucks to do. You have to have crazy callbacks that are embedded in that component that call back a state selector in your parent in order to do all of this. Now, instead of that, the actual action I send to the thing is also capable of doing the updating and triggering that all the way up the tree as far as I need to, wherever it's going to hit that use form status or use form state or whatever of these helpers. And it means that these generics built into React now have behaviors that interface with children automatically. That's interesting. This is starting to click for me. While we initially focused on server actions for client-side data transfer, our philosophy for React is to provide the same programming model across all platforms and environments. When possible, if we introduce a feature on the client, we aim to make it also work on the server and vice versa. This philosophy allows us to create a single set of APIs that work no matter where your apps run, making it easier to upgrade to different environments later. That's an interesting way of putting it. I kind of thought of actions less as a React API, more of a recommended pattern, where it's the method in which you bind things from the server to the client such that the client can update them and send data to the server. It felt like it was describing that relationship more than it was describing the actual behavior of the API. It's interesting to see them really double down on the API and how it works within React. I'm going to have to play with this a lot more. I really feel like I need to understand those hooks better. So make sure you like this video and you give me a subscription because that's going to take a lot of work. New features in the React Canary. We've introduced React Canaries as an option to adopt individual new stable features as soon as their design is close to final before they're released in a stable Semver version. Canaries are a change to the way we develop React. Previously, features would be researched and built privately inside of Meta, so users would only see the final polished product when released to stable. With Canaries, we're building in public with the help of the community to finalize features we share in the React Labs blog series. This means you hear about new features sooner as they're being finalized, instead of after they're complete. This is also huge because the community can give a bunch of feedback and pushback on things. Like the original RFC for server components was not great. I didn't care. I even in my original video called out how dumb it was that you couldn't async await and just await a DB call inside of a server component. And they ended up rewriting the proposal and making the whole thing async await based without weird file pathing. These improvements only happen if the community is involved in the process. Otherwise, there would be too much commitment on a specific way of doing things that no longer makes sense. This is a huge part of how React will continue to win, and it's awesome that they're letting the community be involved. It sucks that this has also resulted in some FUD where people feel like you have to use a canary if you want the new React features. No. You can use the new React features when they're stable, but if you're willing to be part of this experiment where we're learning and figuring out all these pieces, you want to be there as we figure it out and finalize it, you can be now. And there's a whole process and opportunity here to do just that. And Next was one of the few that really jumped on that opportunity. Server components, asset loading, document metadata, and actions have all landed in the React Canary, and we've added docs to these features on react.dev. The directives we've talked about a bunch. I will very quickly say people seem to think these two are like opposites of the same thing, where use servers for server components, use clients for client components. They're not. Don't think that. Check out any of my videos about server actions in particular, because these are for functions that the client calls that are on the server. So if I want to post things to a forum or update my user metadata or something like that, use servers for that. Use client is when I want the component to ship JavaScript to the client. So this is I want to ship JavaScript to the client. This is I want the client to be able to ship data to the server. These aren't opposites. They're different behaviors entirely, and they're bundler features that happen to be built around React. That doesn't mean only React can use them. In fact, Solid is starting to build use server into Solid Start, which is so cool to see other frameworks adopting the opportunities here. They mark the split points between the two environments. Use client instructs the bundler to generate a script tag, similar to Astro's Islands, where use server tells the bundler to generate a post environment, like TRPC mutations. I'm going to take a little moment of pride here. The reason TRPC made it here is because TRPC became a popular thing that nerds like us talk about to discuss modern best practices for full stack web dev. TRPC mutations, and specifically TRPC, got its first big break when I started chilling it really hard. And it's so cool seeing TRPC go from that weird side project that I heard somebody working on that originally came from the guy who made Zen and got taken over by Alex, who pushed it incredibly far. Just a type-safe way to write server functions and call them in React Query. And now it's this legendary moment of time where we realized that the way we were communicating between the server and client was not ideal. So much so that it's being cited next to Astro in the React blog post about what they're doing. It's so cool. Dan Abramov himself even tweeted basically this. He probably wrote this part, to be honest. He specifically said that Astro Islands are use client and TRPC mutations are use server, which is very good mapping if you know how these two things work. Together, they let you write reusable components that compose client-side interactivity with the related server-side logic. Yes, very, very cool stuff. It's once it clicks, you can't go back. Document metadata is an interesting addition here too. We've added built-in support for rendering title, meta, and metadata link tags anywhere in your component tree. These work the same way in all environments, including fully client-side code, SSR, and RSC. This provides built-in support for features pioneered by libraries like React Helmet. Yeah, RIP Helmet and all the libraries that did these things differently. If you're curious why this matters, it's because these all are supposed to go in head, which isn't your body, which is where React normally renders. So if you want to render a title in your component, where does that go? When these are part of the framework, it will handle that and throw it in the right place. That's why React Helmet was previously so valuable, because it would take the thing you put in your JSX, rendered in the virtual DOM, and instead of putting a similar element in the real DOM, it just writes it to head instead. That's why it's Helmet. You can put it anywhere and it goes on top. Asset loading. We integrated Suspense with the loading lifecycle of resources such as style sheets, fonts, and scripts so that React takes them into account to determine whether the content in elements like a style, a link, or a script are ready to be displayed. We've also added new resource loading APIs like preload and preinit to give greater control for when a resource should load and initialize. This is some remix stuff. What's cool here is now if you were to use Suspense to wrap your page because you didn't want to have things flash in, not only is Suspense going to wait for when the components get streamed down, it's also going to wait for when your style tags or similar things load in, so you won't have that flash of unstyled content anymore because it won't flip to the new content until the style tag is loaded. This is really cool. And the fact that they exposed it as a generic API where I'm assuming you can just declare anything as a resource. Yeah, such as scripts, style sheets, and fonts as soon as you know you need them. That's really cool. So you can specify in other places that this might be needed in the future and preload it so that it's ready to go when you make those transitions. Good stuff. I'm really happy that they're more deep in the documentation of these things. That's been a very reasonable critique of this up until now, where there's all these new things happening. We're seeing them on Twitter, we're seeing them in Next, but we don't know how to use them. Where's the docs? Finally, we have some docs being linked. Actions. As shared above, we've added actions to manage sending data from the client to the server. You can add actions to an element like a form, you can access their status with useForm status, you can handle their result with useForm state, and even optimistically update with useOptimistic. When you put it that way, it sounds easy, but the behavior of these things is not as simple as I would like. More coming soon. Since all these features work together, it's difficult to release them in the stable channel individually. For example, releasing actions without the complementary hooks for accessing the form states, that would just limit the practical usability of actions. Introducing server components without integrating server actions would complicate modifying data on the server. As someone who shipped server components without server actions, God bless TRPC. Before we can release a set of features to the stable channel, we need to ensure they work cohesively and developers have everything they need to use them in production. React Canaries allow us to develop these features individually and release the stable APIs incrementally until the entire feature set is complete. The current set of features in React Canary are complete and ready to release. The next major version of React, the thing we are all here for. After a couple of years of iteration, React at Canary is now ready to ship to React at latest. The new features mentioned above are compatible with any environment your app runs in, providing everything needed for production use. Since asset loading and document metadata may be a breaking change for some apps, the next version of React will be a major version, React 19. There's still more to be done preparing for release. In React 19, we're also adding long requested improvements which require breaking changes like support for web components. Can't believe they're actually doing this. They've been punting the ball on web components for so long, and I get why. Because they don't really fit the React model great. But sometimes you have some crappy web component from some third-party provider, like your rate this out of 5 that goes to some third party. Being able to quickly embed that when everything else is React, that's nice. I see why they're finally caving here. Our focus now is to land these changes, prepare for release, finalize docs for new features, and publish announcements for what's included. We'll share more information about everything React 19 includes, how to adopt the new client features, and how to build support for server components in the coming months. I haven't heard them mention off-screen in a while. Oh boy, this is a fun one. It's been renamed, which is a good decision. Off-screen is too in the weeds technically. What the hell are we talking about? Well, let's dive in. Since our last update, we've renamed a capability we're researching from off-screen to activity. The name off-screen implied that it only applies to parts of the app that were not visible, but while researching the feature, we realized it's possible for parts of the app to be visible and inactive, such as content behind a modal. The new name more closely reflects the behavior of making certain parts of the app active or inactive. Activity is still under research, and our remaining work is to finalize the primitives that are exposed to library developers. We've deprioritized this area while we focus on shipping features that are more complete. I'm happy they called this out because off-screen has not been mentioned much. The best I will poorly TLDR it here is it gives you a way to run things in the background such that they're not blocking the main React thread, but they're still going on. So when you change views, like you have a canvas that's been hidden updating in the background and then it reappears, that it's synced already without having to re-render everything. You can keep running the virtual DOM without having the real DOM update until you choose for the real DOM to update. Kind of. in its own thread, it's a lot. In addition to this update, our team has presented at conferences and made appearances on podcasts to speak more on our work and answer questions. Really good stuff here. The 2 React posts, I have a video about that was really good too. Lots of cool stuff here. I need to pull these people on the show more. Normally, I just DM them a bunch and then shout at a camera later on. But this is a great post. Really thankful they've been writing these again. Huge shout out to the whole team, everybody involved, both with the communication of these things as well as actually making these changes possible. Well, that was quite an update. Let me know what you guys think in the comments. And until next time, see you later. Peace, nerds.